Hello, welcome to this screencast that gives you an overview of Eclipse Capra, which is an open-source traceability management tool developed as part of the Revamp project at the University of Gothenburg. Eclipse Capra allows you to create trace links between different artifacts in a development lifecycle. As you can see in this picture, Eclipse Capra is at the center as the connecting engine. It allows you to create links to artifacts in different tools that could be in the organization's toolchain. For example, requirements could be stored in Microsoft Office as Word or Excel files. You can also have requirements in IBM Doors or stored as RecIF files. Additionally, you can link to design models, for example UML, or models in Papyrus. You can also link to source code, for example Java, C or C++, Python, or even PHP. You can also link to tasks which are imported to Eclipse via Eclipse Mylin, as shown here, builds which could be in servers like Jenkins, and other EMF-based DSLs. For example, in this case we have a variability model. In order to understand the different features of Capra, I'm going to show you a tool demo. In this demo, we are going to use an example of a car headlight system. As you can see in the Project Explorer, we have all the projects that we need. The first project contains the feature model, which has several features. For example, dim light, parking light, high beam, fog light, and turn signal. We also have a bunch of optional features, for example, the daylight running light. Next, we have requirements, which are stored as RecIF, and if we open here, we can see that the requirement are simply textual requirements. Then we have the architecture of the system, which is described in this .vacomo file. Now, Vacomo is just a domain-specific language that is used to define system components. If we open this, we will see a couple of components, and here we have the actual instances of the components that have been described here. Next, we have the behavior of the system, which is defined as state charts using the Yakindu state chart tools. For example, if we open one of these state charts, we can see that it contains the actual state machine describing the behavior of the different components. This is the example of the state machine. Next, we have the actual implementation, which is C code. And this is generated C code, which is generated from the state machines. The traceability meta model that we're going to use today allows us to create trace links from features to requirements, and then from requirements to system components, and from system components to state charts, and finally from state charts to the generated code. We are going to use Eclipse Capra to show how these trace links are created. Note that here we have switched to the Capra perspective, which gives you access to this trace creation view. We use the trace creation view to create the trace links. Now assume that we want to create a trace link from this optional feature High Beam Assistant to its relevant artifacts. We first select the feature and then drag and drop it to the selection view. Then we go to the requirement file and look for requirements that are related to the High Beam Assistant. As we can see here, we have several, so we just pick the first one here, which says the High Beam Assistant detects the headlight of forthcoming vehicles from a distance of 1,000 meters. We select this requirement, drag and drop it to the selection view. To create the actual trace link, you right-click on the trace creation view and click on Create Trace. Here you will see a list of all trace link types that are permitted by the traceability meta model that you're using. In this case, a traceability link type between the feature to requirement is called composed of. So then we click on composed of and click OK. The trace link has now been created. As you can see in the Project Explorer, we have one additional project which is called Workspace Trace Models. This is where the actual trace links are stored. Next, let us create a trace link between the requirement and its associated component. So we remove the feature from the trace creation view, remove from selection, and then we're left with the requirement. Next, we'll go to the component model and look for the component that is related to the High Beam Assistant. And here we have the high beam assistant implementation. We drag and drop it to the selection view, right click and say create trace. And here now the trace link type is called satisfied by. Click OK. Next, we create a trace link between the component instance and its associated behavior chart. So we remove the requirement, and then we look for a state chart that is related to the high beam assistant, which is here. Then we create trace, and now the relationship type is described by. Say OK. Next, we remove the component, and we look for code that is related to the high beam assistant. And here we have the high beam assistant. See, drag and drop it to the selection view, click on create trace, and now the trace link type is called implemented by. Now that we have created all the trace links, let us go and look at how we can visualize these links. Capra comes with a view called Capra Plant UML Viewer that allows you to visualize all the trace links that you have created. So if we go back to the feature model, and here we have selected the high beam assistant, if we click on the Plant UML Viewer, we can see that we have a diagram that shows us the high beam assistant has a trace link called compose of to this requirement. Now remember that we created many links, but here we can only see a link from this requirement, from this feature to this requirement. Now this is because the default view of the Capra Plant UML Viewer only shows you directly connected elements from what you have selected. If you want to see more, you click on this arrow here and then click on transitive links. Then you click again on the feature to have the view refresh, and you can see now several links that we have created. So here we see that the high beam assistant is composed of this requirement, which is satisfied by this component, and the component is defined by this state chart, where the state chart is implemented by this code. This view also allows you to filter what you see here based on the levels. So for example, let's say you only want to see these two levels and not the entire diagram. You click here again and say set transitivity depth, and here you can write 2. If you click here again to let the view refresh, you see that now you have a smaller diagram with only 2 levels. To see everything again, you set this to 0. And then you click here and we're back to the original diagram. Next, you can also filter this one based on trace link types. So if you click on select relationship types, you can see all the available trace link types here. And let's say I only want to see the first 2, composed of and satisfied by. And if I click OK, again click here to let the view refresh, you can see that I only have these 2 links types that are shown. To see everything, you go back here and just deselect all, OK, and when you click here again, you have the entire diagram shown again. Next, this view can allow you to actually navigate to the artifacts that are connected to. So for example, if you want to see what is contained in this high beam assistant.c, you can click on go to, and this will open the actual file. This means that you can step into things and analyze what is contained in them. You can also navigate to model elements. So for example, if we want to go to the feature, then we just click here, and again we have it open right here, and you can see that it is shown as the selection. Eclipse Capra also allows you to visualize trace links that are internal to your domain-specific language. For example, if we come to the requirements here, we can see that there are links that are defined within the recif file. So this here means that this requirement has a link to another requirement. Capra can help you to visualize these kinds of links. So if we click on this arrow and then click on show internal links, and then we go and click on the requirement again to let the view refresh, we can see that we have an additional link which is called spec relation that is internal to recif, To this requirement, the high beam assistant turns off the high beams if forthcoming vehicles are detected. As you can see that from this view, it's really hard to tell what this link is to. But with this visualization, we can easily tell that it's to this requirement, which is requirement 1.4.3.3. Capra also provides notification features. So if artifacts connected by a trace link are either modified or deleted, Capra provides warning to the user so that they can also update the associated trace links. So for example, here we have the highbeamassistant.sct, the state chart, linked to highbeamassistant.c. So if we open this C file, let's say make a few changes to it. For example, we add a few additional spaces and click Save. We can see that on the workspace trace models, we have a warning, and if we go to the problems view, we have one warning which says that this highbeamassistant.c has been changed. Please check if the associated trace links are still valid. If we right-click on this warning and go to Quick Fix, we have two options. So the first option is if you want to delete the affected trace link, or if you do not want to update the existing trace link. Now here you have to reason with what change occurred. So for example, since we only added a few spaces to the file, we don't want to delete the trace link, but we want to keep the existing trace link. So you click Do Not Update Existing Trace Link, and then you click Finish. To download Capra and use it either as an end user or a developer, please visit our project page, eclipse.org/Capra. You can also directly contact the developers, Jan-Philipp Steigofer and Salome Maro. Since Capra is open source, new contributions are always welcome. The Capra team would like to acknowledge Philip Hazig for making the example system available for this demo. Thank you for watching.